Research and development on ultra-wideband for a more dependable and secure smart society. The Dependable Wireless Laboratory at NICT's Wireless Network Research Institute develops more dependable wireless network technologies that allow devices to autonomously create networks with nearby devices they detect, even when there is no internet connection. Our goal is to create a next-generation M2M model where every device and machine, from tiny sensors positioned on or around us to airplanes traveling at high speeds, is connected to each other. Part of the work that goes into creating this M2M model is focused on the research and development of UWB. UWB is short for ultra-wideband. While conventional wireless signals occupy bandwidths between several hundred kilohertz and tens of megahertz, UWB sends and receives data at bandwidths of over 500 megahertz at very low power spectral densities. Because of the low power density levels of UWB and the high frequencies they use, signals can only travel up to a limited distance and do not interfere much with other waves. The power density levels of UWB are about 1/10,000th to 100,000th of the signals emitted by mobile phones, so their impact on human health is negligible. Impulse radio UWB, or IR-UWB, is one of the main types of UWB. IR-UWB can be implemented with simple circuits, making it energy efficient and easy to install on small chips that could help lower costs of production. When determining locations using wireless signals, the length of the signal pulse affects accuracy. IR-UWB uses very short pulses of about 1 nanosecond, which allows it to measure distances with a high degree of accuracy. Using the distances to the location measured by 3 or more IR-UWB devices, one can determine the location with a high level of precision. By applying signal processing functions such as correlation and averaging, IR-UWB pulses can be used to measure distances to within a centimeter. This property can be used to develop UWB radars that can monitor the respiration and heartbeat of a person by reading the UWB signals reflected off of them. At NICT, we are developing practical applications that make use of the properties of UWB, such as wearable and implantable wireless biosensors, indoor positioning, and radars for monitoring the respiration and heartbeat of a person. One technology in which UWB can be used is the Body Area Network, or BAN. A BAN is the wireless network connecting the devices on, inside, or in the vicinity of the body. Many wireless devices currently used in the medical and healthcare fields operate on 2.4 GHz ISM frequencies. But because this band is also used by wireless LAN devices, there is always the risk of interference and reduced communication quality. Bands that operate at high-band UWB frequencies allow them to avoid interference, have negligible impact on the body, and are more stable due to their energy efficiency. The NICT-developed health monitoring system is made up of small wearable UWB band devices, such as a bracelet that measures the heartbeat and blood oxygen saturation levels, a pendant that gathers data on heart activity used to produce electrocardiograms, and a device attached to the belt that measures body movement, as well as a device connected to a weight scale and a monitoring computer. Each device uses UWB to transmit data to the belt-attached device, which also serves as a coordinator that sends the accumulated data to the computer. The computer is monitoring the data in real time, and if any abnormalities are detected in the electrocardiogram, body movement, or other factors, an alarm will be triggered, so medical staff can immediately respond to the situation. The IEEE 802.15.6 International Standard for Bands, established in February 2012, incorporates specifications proposed by NICT, such as those related to UWB high band. Bands are expected to play a major role in smart societies as frameworks that will ensure the safety and reliability of not only conventional medical and healthcare equipment, but also a range of wearable devices and implants. Today, we depend more than ever on location information in our daily lives. We acquire location information mostly from the GPS systems installed in our smartphones and car navigation systems. But because such systems rely on signals transmitted by satellites, they are difficult to use indoors, where reception tends to be poor. Another popular way of acquiring indoor and outdoor location information is the use of Wi-Fi devices. However, raising the accuracy requires increasing either the signal strength or the number of access points. As a result, positioning through Wi-Fi may result in interference at Wi-Fi frequency bands. Using its experience and expertise in UWB communication technologies developed through years of research, NICT has developed an indoor positioning system with an unprecedented margin of error of less than 30 centimeters. NICT's UWB indoor positioning uses IR-UWB, which produces ultra-short pulses that last a billionth of a second and allow mobile stations to capture accurate location data in real time. The use of UWB high-band frequencies also helps to avoid interference with existing wireless systems. The UWB indoor positioning system essentially consists of fixed stations, mobile stations, and a control computer. 3 fixed stations, or however many are needed to cover the area, are installed in the ceiling or other high locations in the area that needs coverage. Each fixed station sends UWB signals to a mobile station in the area. The mobile station immediately sends back an acknowledgement signal to the fixed stations. Each fixed station measures the time that the signal travels like a stopwatch, then sends the results to the control computer. The computer uses the time sent by the 3 or more fixed stations to calculate the location of the mobile station. Now let's take a look at one model we are developing. In an indoor navigation system developed by NICT, the mobile station receives location data provided by a control computer, then sends the data to a consumer electronic device connected to the mobile station. A navigation application on the consumer electronic device then indicates the direction to and distance from the destination, while guiding the user by audio.
ディペンダブルワイヤレス研究室です。
Since the application provides information on the destination through audio in addition to video, it can also be used by users who are visually impaired.
出張席へ到着しました。
UWB indoor positioning can also be used to understand the flow of workers and forklifts in a warehouse. Workers, each carrying a mobile station, perform their regular duties as instructed by a pick list. The positions of each worker are sent via a control computer and a data gathering server to a warehouse logistics management server. Product location data stored in the management server application and logistics analysis software are then used to make waste and inefficiency in the warehouse more visible. This makes it easier to review aspects of the operation, such as the placement of racks and workers, and the workflow itself, to create a safer, more efficient work environment. In shopping malls and large supermarkets, users can be guided not only to the shop they are looking for, but also to the very section that is selling the product they want to purchase. Product location and user data could also be used to automatically send the user coupons and product information that best meet their needs, allow for smart ordering solutions, and enhance security for credit card transactions. Such applications of UWB technology can help expedite store transactions and lead to greater customer satisfaction. NICT has developed LSIs that will pave the way for the practical application of UWB positioning. Through various public testing, we hope to eventually develop a new business model that is both technologically smart and intelligent. We believe that UWB positioning is the key to a more dynamic economy and a happier society, where we can always be assured of the safety of our children and the elderly. Through research, development, and public testing, as well as pushes for international standardization and the easing of existing restrictions, NICT will continue to promote the practical application and spread of UWB communication technologies.